Welcome to the workshop. Today we want to take a look at section 5.1, Properties of Trees. So we're just beginning chapter 5, which is all about trees. We'll revisit a lot of things that we've already discussed back in chapter 4 about graphs here in chapter 5. So the first thing though is just an introduction to trees. What are trees and what are some of their properties? Of course, I don't mean the thing that grows out of the ground, though we'll see a connection back to that a little bit later. So let's take a look at our notes. All right. So a tree is any graph which is connected and has no cycles. So again, it's a graph, so we're just returning to the idea of graphs. And then we're just looking at a specific collection of graphs, those which are connected and contain no cycles. So what does this look like? Well, there's still a bit of variety here. There are a lot of different graphs that we can end up with. So let's take a look at just a few examples where some of them are trees and some of them are not. So we could consider, let's see here. We could consider this collection of 5 vertices and connect them like this. It should look somewhat familiar. I can't remember if there's a little handle over here or not, but right, something like the Big Dipper. The Big Dipper. This is a tree, right, where the stars are the vertices, and then when we connect them, we get our constellations. Cool, the Big Dipper in particular here. And this, right, there's no loops. I can't loop around and end up going around in circles, and everything is connected. So this is a tree. All right, so let's look at another example. So let's go with, let's see here, this collection of 7 vertices. So I'm going to connect these guys like that and join these ones here. There we are. And this, as it sits, is not connected, right? I can't get from this vertex to any one of these 4, so this is not connected. So according to the definition of what a tree is, this is not a tree. Okay. So again, we're just looking at some examples to try and get an idea of what is a tree and what is not a tree. That's all we're looking for here. So let's look at another example. Let's see, go with several vertices again. Something like this. Quite a few vertices there, and I'm going to connect a whole bunch of these together. And like this. Yep, that's fine. That'll work. And right there. Cool. This is a tree, right? There are no cycles. I can't end up going around in loops for a while. And it is connected because I can get from any vertex to any other vertex. So this is connected and it contains no cycles. So this is a tree. All right, let's look at one more example. So I've got, let's go with several vertices, 6 of them arranged as vertical lines. And let's go with a few more like this. Let's move those over. There we go. So I'm going to connect these ones on the sides. And I'm going to connect these ones like this. There we go. Now, does that look familiar? Yes, no, maybe. If you're a fan of Star Wars, you would recognize this as the fighter that the stormtroopers fly. Excellent. Anyway, so there is a loop right here. All right, I could just keep going around and around. I could create a cycle or a circuit, however you'd like to call it. And this is not a tree because of it. Not a tree because it contains a cycle. If I wanted to be specific, I could label these A, B, C, D, and it contains the cycle A, B, C, D, and we can return back to A. Excellent. So that is some examples of a tree and what is not a tree. So I just wanted to give that introduction. And then in the next several videos, we're going to look at some properties of trees. And we'll try to look at some examples, but our last video will be a nice example as in an application of some of the properties that we've learned. So I'll see you guys back in the workshop very shortly for more on trees.